For this webinar, I'm joined by our speaker Vijay, working as a product analyst and consultant with us in the Center of Excellence. He is a data science expert and has been into research and development of emerging areas of machine learning and deep learning. Overall, he has extensive experience grown from a career path built on background of consulting, IT operations, and pre-sales that includes product management and solutions architecture. Both from an end user and system integrator base, he has an experience. And in today's session, we will discuss about the process of AI and the key applications of this emerging technologies. And we'll also deep dive into a preliminary review of machine learning algorithms and how they work in a business landscape. Without further ado, let me hand over the controls to our speaker.
Thank you so much, Richa. Hello everyone, hope you're all doing good. My name is Vijay. So we'll start off with today's topic, and that is the business side of modular, artificial intelligence and machine learning. So there's a list of topics that we'll be covering today. To start off with, we'll have a brief introduction about our organization, Tori Harris, and we'll see how AI is being used in present day businesses and different ways to implement them with a few examples. We'll also touch upon a case study on how 5G connectivity is being used with artificial intelligence and computer vision for real-time analytics. And to conclude, we'll discuss about how Tori Harris as a company is addressing the challenges in implementing AI solutions and is contributing to the development of AI in the real world. So we at Tori Harris have been in the business of delivering business excellence for the last 20 years. So we have expertise in accelerating digital transformation initiatives and digital marketplace strategies as well. So we do this by providing a wide range of solutions. And in this webinar, I'll be talking about two interesting products that are related to Internet of Things and analytics. So before we talk about artificial intelligence and machine learning, first we need to talk about the first programmable computer that was built and the man behind it. So the picture that you're seeing on the screen is called Colossus. It is a computer that was built by Alan Turing. So this particular machine helped the Allies win the World War II and defeat the Axis powers basically. So they have done this by intercepting the messages between the German High Command and the Army Field Commanders. And the man you're seeing on the screen, he is Alan Turing. So he wrote a research paper in 1950 and he proposed a pretty interesting question in his research paper. And that is, can machines think? So we have the definition of artificial intelligence in this particular question. So artificial intelligence is basically simulating human intelligence through computer systems. And we can see that everywhere. So the best example that I could give you is the one which we use daily. That is Google search. Whenever you search anything on Google, so you're basically utilizing the background models, machine learning models to get us the best results. And this is the second example that I could give you is voice assistant Siri. So whenever you talk with your voice assistant, you are utilizing a machine learning model called natural language processing. So it basically decodes your voice and gets you the appropriate response. So all in all, we can say that artificial intelligence is one of the biggest scientific breakthroughs in the 21st century. So keeping these things in mind, we'll try to answer a few questions related to artificial intelligence in this webinar. So when you look around, right, artificial intelligence is like everywhere. It is in our phones, it is in our cars, it is in our factories, it is in our home. So there is artificial intelligence everywhere. So when you look at it, at least I got a feeling that how can I build those particular machines, and how would our future look like if we have those intelligent machines around us. So before we answer these two questions, first we need to address the most important question here. Why do we need artificial intelligence in the first place? So in the next slide, the slide which you are seeing, it is a comparison between the top 5 companies with respect to market capitalization from 2006 to 2022. So if you look at it closely, something fundamental has changed. Like the technology companies have took over the traditional energy and banking companies. So why did this happen? So technology companies are very flexible. They adapted to the change in technologies very quickly. But banking and energy sectors being very traditional, they couldn't adopt. So that is why, except for Microsoft, which is a technology company, all others have dropped down and the technology companies took over, except for Saudi Aramco, because they have been implementing AI and ML solutions in their organizations and they are doing it quickly. That is why they were able to maintain their position in the top 5. So it is very important that we identify AI and ML opportunities in our organizations to stay relevant down the line. So how did these companies identify AI and ML opportunities in the first place, and what can we learn from them? So to identify AI and ML opportunities in business, we need to think about a problem statement first. So you'll find problems in the depending on the way your organization works basically. So let's say that in my organization, I want to improve my IT help desk. What can I do with AI and ML to improve my IT help desk? I can deploy a chatbot to answer frequently answered questions, frequently asked questions. So by deploying this particular AI and ML machine, I can decrease the load on my IT help desk people, so thereby improving the efficiency. And the other way is to solve problems for the clients. So the B2B and B2C sector is pretty interesting when you talk about AI and ML solutions, because you are solving others' problems and it is you have a constant feedback loop. You can improve your products constantly depending on the feedback. But one thing that we should keep in mind is you need to have a clear strategy and a roadmap. If the problem statement is clear, depending on that, you can choose which type of technology that you want. And B2B, we already have a lot of products that voice assistants are there in our home. We talk with them and a lot of data is being collected already. So using that particular data, the big organizations like Amazon and Google are improving their products internally. So using this particular feedback that we have, we can improve our businesses if we are able to identify the problem statement in the first place. So that is pretty important when you consider about identifying opportunities. So how can AI and ML solutions can be implemented? We have different ways to talk about a few. The first important branch is like machine learning. So machine learning is basically you are using statistics to develop models. And then you have neural networks. Neural networks, let's say that you have developed a machine learning models. You are using neural networks, which is based on how human brain works, to improve the accuracy of that particular model. And then you have robotics. Robotics, we already have this in operations. These can do repetitive tasks. These are doing repetitive tasks in our factories. And you have expert systems and fuzzy logic. Basically, these systems are there to assist human beings and also take decisions without the intervention of human beings. And finally, we have NLP. NLP, as I told you, voice assistant is the best example. So these are the different ways that you could implement AI, and the most important thing out of these six is machine learning, because machine learning is considered as the backbone of artificial intelligence, and there are different ways to implement machine learning. So the first one is supervised. When we talk about supervised machine learning models, here we are dealing with labeled data. You know what you are dealing with. Like, let's say that I want to predict the quantity, how many goods will be sold down the line. So if you're dealing with such type of problem statement, then it is supervised machine learning. And when it comes to unsupervised, it is opposite to supervised. Here you do not know what you're dealing with. Here you have neural networks, and then there is principal component analysis. And with supervised learning, it is basically classification and regression. And when it comes to reinforcement learning, it is neither supervised nor unsupervised. So you could find this in gaming and robotics. To understand about reinforcement learning, Boston Dynamics have been developing robots for the last 10 to 15 years, like to do trivial things like how to lift an object, how to go from here and there. So those trivial things are very difficult for robots. So for developing those type of robots, we need reinforcement learning. So that is the best example. So like fundamentally, you could say that artificial intelligence is the bigger branch, and machine learning is a subset of artificial intelligence, and then you have deep learning, which is a subset of machine learning. So let's see the difference between these three: artificial intelligence, ML, and DL. So when can you say that your machine is intelligent? If it can think logically, if it can learn and correct by itself, then you can say that yes, my machine is artificially intelligent. How can you achieve that artificial intelligence? By using statistics. You are using numbers to approach a problem, so the probability of solving a particular problem increases. So you use statistics and develop algorithms that can learn automatically. So to improve the efficiency of models, you use concepts like deep learning, which are inspired by human neurons. So by implementing all these three, you could develop a perfect artificially intelligent machine. We all use a particular machine which uses all these three things to work. That example is Google Translate. The image that you are seeing is a neural network picture of how Google Translate works. So it looks so complicated, but trust me, the working of it is pretty simple. So if you see it from the last 10 years, from the outside, Google Translate hasn't changed at all, but the accuracy of the Google Translate has increased, and now it can translate it to more and more languages every day. So how is Google managing to do all this? The answer for that particular question is data. So there's an estimation that Google has around 15 exabytes of data. To give you a context of that particular number, an exabyte has around 18 zeros. So 15 followed by 18 zeros. That much data. By utilizing this data, Google is able to give us accurate results with Google Translate. So let's see the functioning of Google Translate with the help of a flowchart. So what as a user can see, I'll be entering some input here and I'll be able to see the output. What I want to translate, the model background working would translate some information for me. But how is Google managing to do all that? So the key fuel, you might have heard data is the new fuel. So Google's data, because of Google's data, you're able to translate that particular information, and that too accurately. The main component in this example, you might say, is a learning algorithm. So let's see what learning algorithm is. So we'll talk about learning algorithm with the help of two things here. First is image processing, and then we'll talk about neural networks. So to talk about image processing, we need to understand how a human visual cortex works. So this image might be overwhelming, but this is just to understand how computer processes an image. So whenever you see an object, right, we perceive that particular information in the form of light. So that light passes through our eyes, our retina, and then it passes through different layers. First, it passes through the primary visual cortex, then secondary, then tertiary. So basically, it is divided into 3 layers. Then you are processing that particular information. In the same way, for computer, a particular image computer process in the form of pixels. So that is why a company, an animated studio company, which was once funded by Steve Jobs, is known as Pixar. So that is one interesting thing that we could relate to. So let us understand all this process in the form of an example. Let's say that I have this particular image where you could see there are clouds, there is sun, and there is a mountain. How does a computer process that particular image? So what it basically does is it identifies different objects in this image and it assigns attributes. What I mean by attributes is a model can have 3 attributes or 20 attributes or 50 attributes depending on its capability. So to show you a simple example, my model identifies this particular sun and assigns area, perimeter and the skeleton. In a similar way, it identifies the clouds and the mountains. So combining all these 3, it would be mapped to this particular picture. In this way, a computer identifies this particular image. Now let's see this particular process in the form of a flowchart. So here there's input. You'll be have an algorithm would process my input data and give a meaning to it. So here the input is in the form of pixels because it is an image. My algorithm would run that particular image and assign some attributes to it. Here it is area, perimeter and skeleton. And then it is able to identify that, okay, yes, this is the picture. Now let's say there are raindrops. I mean, it is raining in that particular picture, but my machine is not able to identify those minute details. Now, how do you identify those minute details? That can be done in the form of, I mean, if you implement neural networks to that particular model. So here you are able to identify minute details and then you are improving. There's a loop here. So let's talk about neural networks. Neural networks. So to understand again about neural networks, we need to understand how human neurons work, biological neurons work. So there is a cell body and there is an axon where the image from the cell body is transmitted to the synapses where it is connected to other neurons. If you group a lot of neurons together, it is called a network, right? So in a similar way, what I'll do is I'll create an artificial neuron and pull a bunch of neurons together. So this is how it would be. Like I have a neuron and it is connected to other neurons. So I have an input here, there's a hidden layer and an output. If you compare these 3, input can be considered as a cell body and it is transmitting information from here to the hidden layer. Some data processing is going on and then my output is generated. So if there are a lot of permutations and combinations going on here, that is how you get accurate results if you use neural networks. So let's see this particular thing in the form of an example. Like let's say that so this example is on convolution neural network. So this is one of the most widely used neural networks for image processing. Let's say that there's a application that we have developed which has convolution neural network in it. I'll use my phone to scan handwritten images. So my objective here is to find out what is the handwritten number. Now I've written down 7, 5 and 8 here. And these things you are seeing are the network activations. You can consider these as attributes. So if I use my phone's camera to identify this particular image, what my CNN model would do is it would assign some values to these attributes. As you can see, this is number 7. So here the label, it is labeled from 0 to 9. So 7 has the highest rating here, 0.7, 0.97. And in a similar way, 5 and 8 have the highest rating. So in this way, my convolution neural network would assign some attribute values and then gives me a perfect value. So the accuracy of this model depends on how well you train it. So you need data on how you train it. Like you write different ways. I mean, you write different handwritten numbers and then you train your model so that down the line the accuracy is like almost 100%. And you could use these particular neural networks in all in different sectors. That is, you could use it in medical sector or even banking or even in telecom. So you could identify customer behavior and different segmentation using this neural network, because by using computers you could have perfect results because the data is huge and only neural networks can solve the problems, especially the present day problems. Now we'll see a particular case study on how a company in Norway is using 5G connectivity, artificial intelligence and computer vision to solve its problem. So the company in question is Cermaq. It is a Norwegian based fishing company. So the problem statement that they had was there was uneven growth of fish in each and every farm. So to solve that particular issue, what they have done is they have deployed 5G connectivity. They've removed the traditional cables, like long internet cables. They've removed those and they've deployed 5G, basically 5G towers. And also they've deployed cameras into each and every farm. And they also deployed these automatic feeding machines. What they've done is pretty interesting. They identify each and every fish and feed them accordingly with the help of feeder machines, like automatic feeder machines. And they do it by using the feeding patterns of the fish. So they're basically analyzing the past data and identifying which fish didn't eat in the last 30 minutes and feeding it with the help of a robot. So this is something amazing that you could do with the present day technology. So this particular company has implemented this AI solution, right? So let's talk about the challenges companies face while implementing AI and ML solution. The first thing we need to understand is, why do we need AI? Like, we need to have a clear strategy. As in the case study, they've identified that using long line cables and 4G connectivity, it won't help them in real time to find out real time analytics. So what they've done is they've invested some money and they've deployed 5G connectivity solutions over there. But it is not a solution for each and every company. So you need to identify which direction you want to go when it comes to AI strategies. That is a major thing. And when you talk about technology, you are dealing with loads of data here, and you need infrastructure as well. Also, you need workforce who know what they are doing basically. So if you have this particular branch ready, then you can think about solving the problem statement using artificial intelligence and machine learning. And then finally, the most important thing here is ethics, because nowadays privacy plays a major role. Because you are dealing with sensitive data here, you need to be very careful while developing AI and ML models, and this can be done only with the help of the stakeholders. So keeping all these challenges in mind, Tori Harris as an organization developed a few products. I mean, The first product is loTglue. It is basically an Internet of Things product. It is used to build IoT ecosystems faster. And then we have Foresight. It is an analytics prediction framework. So where you could build dashboards, you could view how your business is performing, and also you could create predictive models without any code, without the prior knowledge of coding and all that. So I have a small use case on how you could use these two products in tandem to make your business more efficient. So let's consider that you have a fleet of 10 different vehicles. The problem I want to solve is I want to make my fleet more efficient. So I want to develop a fleet management solution. How can I do that is I'll deploy an onboard diagnostic device which captures the information about temperature, the location, and about the engine. So I'll deploy that OBD device on my vehicle, and we'll also have a wireless gateway, where all the collected information would be sent to the cloud. And from the cloud, using my product loTglue, I'll subscribe to that particular information. I'll collect that data and I can set rules to it. Like, let's say that I want to find out which driver is exceeding a certain limit. So if that happens, I'll be notified. So those type of rules can be set through our product. So I'll take it a step further. I'll extract this particular data from my machine, from my vehicle, and then I'll push it to my product Foresight. So what I'll do here is I can develop widgets, I can develop dashboards, and on top of that, I can create predictive models. Basically, by doing this, I can predict what will happen in the future for my fleet management solution. Depending on that, I can take business decisions. So I'll quickly swap my screen to show you how these two products look like. So this particular product that you're seeing is loTglue. It basically has three different components. One is Commune, RT Builder, and X Builder. What I'm doing here is I'm mapping different sources here. So if it is a IoT device, I can map it, or even if it is a web service, I can do that. I'll be collecting the metadata from this source and mapping it in this particular product. For example, for this fleet management, what all information do I need? I need the driver information, I would need the speed, I would need the location. So all that particular data can be collected using this particular section in my product. And for that data that I've collected from my source, I could assign some rules. As I said, if a driver is exceeding a certain speed limit, I'll set that particular speed limit here and an action here. If let's say that it is exceeding 60, then an email would be triggered. An email or an SMS, I could set it accordingly. And also I could create complex flows using this particular product. So I'll be informed real time using this particular product, and also I could create widgets and dashboards accordingly. So I'll export this particular data into my product Foresight here. So where I'll be creating dashboards. So I have a sample dashboard created for this IoT use case. So I can view different information like how is a particular vehicle doing, what is the average speed of all the vehicles in my fleet. All those information can be viewed using this particular product. And the USP of our Foresight product is I can create predictive models. Like I can experiment without actually having a knowledge on how to code and all that. So we have like supervised machine learning models, and depending on the use case, depending on the problem statement, we have a framework ready, so we could add more and more algorithms here to solve our basic problems. Also, we have alerting mechanism. As you could see, if a vehicle is speeding, I mean, if my product detects a vehicle speeding, it would trigger an alert to the mails and all that. All those things are also possible. So these are different things I could do. I mean, this particular technology amazes me each and every time. So that is all from my side.